everyone, I'll be going over 3 useful foma features today. Number 1, pairs. Number 2, apply up. Number 3, apply down. At a high level, the foma compiler converts regular expressions to finite automata and transducers. Some of the finite transducers can get very elaborate and make it increasingly difficult to quickly check whether something is a valid input. That's where apply up comes in. As you can see here, I have both a lexc file and a foma file in my directory. My lexc file has an initial lexicon with entries on the left-hand side and the corresponding continuation class to the right of it, leading down to the final states of my entries, which will be marked by the hash marks below. So my foma file first reads the lexc file and defines the network. So if we go ahead and compile this now, and then go to the foma prompt, we can enter up, and then we will end up with the apply up prompt. Apply up looks up words in the inverse direction or the analysis direction of the transducer. So if we type in car, we can see what the input side would have been in order to generate car on the output side. Theoretically, it should print out the underlying form right afterwards. But if the word entered wasn't recognized by the network, then we would end up with a line of question marks. For example, if we enter in truck, we will get the line of question marks. Apply down, on the other hand, runs in the generation direction. We can check to see that inputs get transformed as expected. If we enter in down and then at the apply down prompt enter in the input, we can check to see if the transducer accepts it and what the surface form would be. In this case, if we enter in tree with the following multi-character tags, to see what the transformation would be, we should end up with trees. Now if the transducer does not accept it, we'll end up with a series of question marks again. Lastly, pairs combines both the apply up command and the apply down command, in that applying pairs allows you to see the underlying form on the left-hand side and the surface form on the right-hand side. Because the underlying form is the phonemic representation of the entry and the surface form is the entry after the rules have been applied, we can better understand how the transducer analysis works for the transformed entries, as well as the corresponding output for the input entry based on the rules defined. Let's look at a more complex example now. In this lexc file, we're looking at a few prefixes and the verb soap in the Klingon language. The multi-character tag on the left side of the prefix provides information about the subject and object in the scenario. So if we're trying to say it eats you, with soap meaning eat, then at the apply up prompt, we can enter in do soap to get the underlying form for that input. Conversely, if we enter in the surface form, Or rather, if we enter in the form with all of the underlying form with all of the multi-character tags, then we will get the surface form, which is just the Klingon translation of "it eats you." And just as in the last example, entering in pairs at the prompt will print out all of the underlying forms on the left side and all of the surface forms on the right side.